Hello students and welcome to the lecture. So students, as you can see here that basically in this lecture we are going to start our discussion over the upthrust in fluids. Okay, this is going to be a part 1. Okay, upthrust in fluids. In this lecture we are going to talk about the upthrust or buoyancy, effect of upthrust, Archimedes principle, density, relative density, principle of flotation, equilibrium of floating bodies, meta center. So these are going to be a point of discussion in this particular lecture, like upthrust or buoyancy, effect of upthrust, Archimedes principle, density, relative density, principle of flotation, equilibrium of floating bodies, and the meta center. Okay. But before starting all of these, there is a small disclaimer over here that we are required to understand before we proceed further. The disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this tag and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Now, let's begin with the upthrust or buoyancy. What do we mean by this? So, here you can say when a body is immersed in a liquid, the liquid exerts an upward force on a body which is called the upthrust or buoyant force. If you ever tried this in your bathroom, basically, like if you're having a bucket full of water, you're having a mug. So whenever you try to immerse that mug in that bucket full of water, you will always feel a force. Okay, like you will force, suppose if this is the bucket and this is the mug. So when you try to push it down inside the water, you will feel that there is a force upside that mug. You will feel a force, you will feel a pressure on that particular mug, right? This is called buoyant force or upthrust. Okay, simply speaking, whenever we try to immerse any body in a liquid, okay, so we are trying to push it down, we are trying to downward force. Similarly, the water is trying to give the upward force. Okay, and that force is the force that we call as the upthrust or buoyant force, and this is the same force that we feel whenever we try to sink the mug inside the bucket full of water. This property of liquid is famously called as the buoyancy. Okay, so if anyone asks you like what do you mean by the buoyancy, so you can say buoyancy is the property of liquid by virtue of which the liquid exerts a upthrust or buoyant force over the object that is to be immersed inside the liquid. This force could be greater than, equal to, or less than the weight of the body. All the three conditions could be there. Okay, maybe the force that has been applied by the fluid or the water upside the body, maybe it is greater than the weight of body, maybe it is equal to the weight of body, maybe it is less than the weight of body. Okay, and this determines whether the body will float or sink. Okay, so these three conditions actually are the determiner to decide whether that body will sink in the water, will float in the water. So you can say if this is a bucket, okay, full of water, and here if you are trying to dive this mug inside the water, okay, so it is totally depend upon that water and the force, sorry, upon that particular mug and the force. If this mug weight is greater than the force, equal to the force, or less than the force, then it will be decided whether this mug will float or sink inside the water. Got it? Now, effect of upthrust. It is due to the upthrust that the weight of the body immersed in a liquid appears to be less than its actual weight. Okay, like we can say whenever we try to immerse any body inside a liquid, okay, so whatsoever the weight of that body will be, that weight will always be appear as the less weight than the actual weight. Okay, why it is so? The upthrust due to the fluid on a body depends on the following two factors. First, the volume of the body submerged in the liquid or fluid. Larger the volume of the body submerged in the liquid, greater is the upthrust. For example, if a feather and the stone of same masses are allowed to fall in air, the stone falls faster than the feather. Or we could say, like if you look at here, what you are seeing? You are seeing that there is an weight of 10 kg. Okay, so when you immerse that 10 kg weight inside the liquid, you will face that therefore because this 10 kg object displaces the 4 kg of water. Okay, so what will happen? This 4 kg will be a displacement weight. So that's why the object that was previously of 10 kgs now will be for only 6 kg under the water. Why? Because the 4 kg of water have been displaced. Okay, so greater the force means if the greater portion of that particular object immersed inside the liquid, the greater will be the buoyant force. For example, if you're having a bucket full of water, you're having a mug in your hand. So if you immersed only a bottom of that mug, you won't feel that much of force. But if you try to push it down, if you try to push down entire mug inside the water, you will face a large magnitude of buoyant force. Why? Because right now the volume of the body that is being submerged in the liquid is getting higher, and when it is getting higher, automatically the upthrust is getting higher. Got it? That is the reason why whenever any body immersed in the liquid, its actual weight is appears less. Okay, now the effect of upthrust. So we could say if we drop down a stone and a feather in the air, so we could say the reason is that the upthrust due to air on the stone will be less than on the feather, because the volume of stone is less than of the feather of the same mass. Okay, in vacuum, since there is no upthrust, both fall together. The density of liquid or fluid in which the body is submerged, this is the second condition. More the density of liquid or fluid, greater in the upthrust. So you can say the density of the fluid also decide what will be the magnitude of upthrust. For example, you can say if you are having a boiled water and if you are having a cold water, so the density of boiled water is less than in comparison with the cold water. Why? We will look into it when we will talk about the density. Till now, just remember, the boiled water will have a less density, cold water will have a high density. So now if you are trying to immerse the mug inside the water, in both the cases, in boiled water and in cold water, so you will find out it is easy to immerse the mug inside the boiled water than cold water. Why? Because here you can get the answer. The boiled water having a low density, so that's why the upthrust that is being applied on that particular mug is less, while the cold water is having a high density, so the mug is experiencing a greater upthrust. Okay, so the density of the liquid or fluid is actually defined why it is hard to face the upthrust in the cold water rather than facing the upthrust in the boiled water. Now, Archimedes principle. What do we mean by this? So basically there was a very famous person whose name was Archimedes. So he gave his principle, and as per the principle, we could say Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. Okay, so we could say, suppose here in this picture you can say there is a weight of 5 kg, and there you can say this is a liquid. So when we immerse this liquid in this 5 kg in this water, okay, so now you can say 2 kg is the upthrust. If you look at here, you will find out that 2 kg is the upthrust, and here you can say some of the water also got displaced, right? So now if you compare it, 2 kg of water, 2 kg of upthrust, what you are getting exactly? You are getting that the weight of the displaced liquid is equal to the weight of upthrust force that is being applied. And that was the Archimedes principle. Like the weight of the body, the upthrust being applied on the applying on the object, getting immersed in the liquid, equals to the displaced amount of water or displaced amount of liquid. Got it? This principle applies not only to the liquid but also applies equally to the gases. Okay, like here again, let me tell you, 2 kg was the upthrust force, 2 kg was the weight of the displaced liquid. Both are same. That is what the Archimedes principle. Now let's have a talk over the density. So whenever we talk about the density, actually it comes in our mind that density of various types. Okay, like many times we use it to define a population of any area. For example, if you are tracking down the census for population, you have seen it like the density of Uttar Pradesh is higher than the density of Rajasthan. Or you can say the most dense state in India is Bihar, while the less dense state in India is Arunachal Pradesh. Okay, so we often use density in that scenario also. In physics, we use density oftenly. Okay, so what do we mean by density? It is what we require to understand first, because on the basis of our understanding regarding the density, we will be able to conclude a fact why it is used in these scenarios. Okay, so we could say in the scientific term, the density of a substance is defined as its mass per unit volume. Okay, mass per unit volume, or we could say how much mass is present inside the body in comparison with the per unit volume of that body. That is what defines the density of a substance. In the CGS system, the unit of density is gram centimeters power minus cube. In the SI unit of density, it is kilograms meters power minus cube, where 1 gram centimeters power minus cube equals to 1000 kgs meters power minus cube. Density of most of the substance decreases with the increase in temperature and increases with the decrease in temperature. Remember it. This is the golden sentence or golden statement, you could say, that will be useful for us further also. Density of most of the substance decreases with the increase in temperature and increases with the decrease in temperature. So why it is happening? Let me tell you in a very layman terms, in a very simple language. So here, if you look at this picture, what you are getting? You are getting this is solid, this is liquid, this is gaseous. And here you can say these dots, these little circles that you are seeing, these are actually the atoms. Okay. So if you look at this solid, what you are seeing? That the atom's mass is higher in per unit volume in comparison with the liquid and gas. Whereas you can, if you look at this, you will find out that the mass per unit volume of liquid is higher than the gas, lower than the solid. And here you can say the mass per unit volume of gas is totally lower than the liquid as well as the solid. Got it? So that's why we could say the solid having a high density in comparison with the liquid and gas. Okay, so these atoms basically binding together through the intermolecular force. Intermolecular force is the force of attraction between the molecules or the atoms inside any body. So when the temperature increases, actually the kinetic energy of these atoms also increases. And when their kinetic energy increases, they start moving here and there. And when they start moving, so automatically their intermolecular force decreases. And because the intermolecular force is getting decreased, so that's why the mass per unit volume is also decreasing. That's why the density is decreases with increase in temperature. But on the other hand, when the temperature is getting decreased, temperature is lowering down, okay, automatically the kinetic energy of these particles or these atoms getting decreased. And when the kinetic energy is getting decreased, automatically the intermolecular force is increasing. And when the intermolecular force increasing, so mass per unit volume of these substances, gas, liquid, solid, also increasing. So that's why the density will increase. Okay, so remember, density of most of the substance decreases with the increase in temperature. Reason I have told you, increases with the decrease in temperature. Okay, but water contracts when cooled up to 4 degrees Celsius and expands when cooled further below 4 degrees Celsius. Okay, thus the density of water is maximum at 4 degrees Celsius. Remember this, in water the case is somewhat different, like it contracts when cooled up to 4 degrees Celsius and then it expands when further cooled below the 4 degrees Celsius. Thus the density of water is maximum at 4 degrees Celsius and then it starts decreasing. At 4 degrees Celsius the water density is 1 GCM's power minus cube or 1000 kgm's power minus cube. This is the density of water at 4 degrees Celsius, that is to be remembered. Now, I hope the density is cleared in your mind. It is the mass per unit volume of a substance. Now, what do we mean by relative density? So if you look at this, you will find out that this is made up of two terms, RD, relative density. Okay, so basically here we are going to talk about the density, but we will relate it with some other substances also. So when we talk about density, normally we're talking about only one substance. Okay, for example, if we're having a two liquid, 1 and 2, liquid A or liquid B. So when we talk about density, so we will talk about on the individual basis about liquid A and liquid B, like liquid A density individual, liquid B density individual. But when we take this into the consideration of relative density, basically we will now start comparing them. What is the density of liquid A related with the density of liquid B? This comparison will start, that is known as the relative density. The relative density, also known as RD, of a substance is ratio of the density of substance to the density of water at 4 degrees Celsius. Or we could say RD is equals to density of substance by density of water at 4 degrees Celsius. Why we are taking this 4 degrees Celsius? Now it is the thing that is to be taught. Basically, the water having a maximum density at 4 degrees Celsius. That's why we are considering the 4 degrees Celsius as the maximum density of water while we calculating the relative density. So relative density is equals to density of substance by density of water at 4 degrees Celsius. Got it? It is equals to mass of unit volume of substance by mass of unit volume of water at 4 degrees Celsius. Okay? Don't get confused by this. mass of unit volume of substance by mass of unit volume of water at 4 degrees Celsius. Why? Because as we know, the density is mass of unit per volume. Okay, so that's why whether we write it as a density of substance by density of water at 4 degrees Celsius or mass of unit volume of substance by mass of unit volume of water at 4 degrees Celsius, they both are same. There is no difference. Got it? It's equals to mass of a certain volume of substance by mass of same volume of water at 4 degree Celsius. Okay, there is no difference in them. Thus, the relative density of a substance also defined as the ratio of the mass of substance to the mass of an equal volume of water at 4 degree Celsius. Since relative density is a pure ratio, it has no unit. Why? Because it is only a ratio, it is not having any other kind of thing. Relationship between density and relative density could be understood by this. In CGS system, the density of water at 4 degrees Celsius is 1 GCM power minus cube. Therefore, the relative density of a substance is equal to the numerical value of density of that substance. Thus, the density in GCM power minus cube is almost equal to the relative density. Okay, because it is nearly equal to the numerical value of density of that substance. So that's why it is always equal to each other. In SI system, the density of water at 4 degrees Celsius is 1000 kgms power minus cube. Hence, the relative density is equals to RD equals to density of substance in kgm by minus 3, or density in kgms power minus 3 equals to RD into 1000. Okay. Now, let's have a look over the principle of flotation. This is what we are required to understand, the principle of flotation. So basically, you have seen out many times, like if you're having the two objects in your hand and if you throw them in the water, you will find out that one object will sink in the water immediately, one object will start floating on the water. Okay, so it is always you can sense of wonder for us to calculate that why some object floating on the liquid or water, why some object sinking in the water. Okay, so if we really want to understand this kind of thing, we have to go by the principle of flotation. If we are able to go by the principle of flotation, we will be able to talk about it. So when a body is immersed in liquid, the following two forces act on it. Okay. First, the weight W1 of the body acting vertically downwards through the center of gravity of the body. Okay. Second, this force having a tendency to sink the body. The upthrust W2 of the liquid acting vertically upwards through the center of gravity of the displaced liquid, called the center of buoyancy. The upthrust is equal to the weight of the liquid displaced. So these two are actually the main forces that act on a body whenever immersed in a liquid. First, its body's own weight, that is running vertically down, okay, following the center of gravity of the body, and it is having a tendency to sink the body. Secondly, upthrust W2, that is the upthrust of the liquid that is actually acting upwards through the center of gravity, not of the body but of the displaced liquid, because as we know, whenever we immerse any particular body inside the liquid get displaced. Okay, and this is now known as the center of buoyancy. So the upthrust or buoyance force is equal to the weight of the liquid displaced as per the Archimedes principles that we have just seen. Got it? So now we could consider the three following cases from this phenomena. Case 1, when the body weight is lighter than the displaced liquid weight. Okay, sorry, greater than. So we can say the body weight is greater than the weight of the displaced liquid. In this case, the body will sink. Here you can see it. Body weight is higher than the weight of the displaced liquid. So maybe the body was there, but ultimately it came here, which means that it got sinked. Okay. And its apparent weight, therefore the weight inside the liquid will be body weight minus the weight of the displaced liquid acting vertically downwards. This is the case when the density of the solid is greater than that of the liquid. Okay, remember this, density of solid is greater than the density of liquid. So that's why the weight of the body is higher than the weight of the displaced liquid. Okay. Second case, when the body weight is equals to the weight of displaced liquid. Okay. In this case, the body will float just inside the surface of water. Now here you can see this case, B case. Okay, this one. So body weight equals to the weight of displaced liquid. Now you can say this body is not getting sink, but it is floating, but inside the water. Inside the water it is flowing, and its apparent weight will be 0 because no force will act on it. The density of such a body is equal to the density of the liquid. Here D is equals to dl. Okay. Third case, when the body weight is lesser than the displaced liquid weight. In such a scenario, obviously in this case the body will float partially above the surface of liquid. Only that much portion of the body will emerge by which the weight of the liquid displaced balances the total weight of the body. So here see, you can look it. Okay, so here you can say it is the water surface. Only some portion of the body inside the water and maximum portion is outside the water. Why? Because weight of the body is lesser than the weight of the displaced liquid. Thus the apparent weight of the body will be 0. The density of such a body is less than the density of liquid. Note, according to the principle of flotation, the weight of floating body is equal to the weight of the liquid displaced. So now, according to the principle of flotation, we have seen the 3 cases. First case, when the body weight is greater than the weight of displaced liquid, the body will sink into the water. In such scenario, the density of solid is higher than the density of liquid. Second case, body weight equals to the displaced liquid weight. The body will float immersing the water. Here, the density of solid equals to the density of liquid. Third case, body weight is lesser than the weight of the displaced liquid. In such a scenario, the body will partially inside the water and partially outside the water, and the density of solid is lesser than the density of liquid. Okay, now let's have a look on the equilibrium of floating bodies. For a floating body in equilibrium, the following 2 conditions must be satisfied. Then only we could say that particular body is in the equilibrium. First, the weight to the body W1 must be equal to the weight of the liquid displaced W2. So when the weight of the body and the weight of the liquid displaced is equal, first condition. Second, the center of gravity G of the body and the center of buoyancy B of the displaced liquid must lie in the same vertical line as shows in the figure. So here you can say this is the center of gravity of the body and this is the center of buoyancy of the liquid. Now here you can say they both are in the same line. Okay, and the weight of the body is equals to the weight of the displaced liquid. When these 2 conditions satisfied, then we could say that the body is floating in equilibrium. Got it? Now, what do we mean by the meta center? This is to be understand. So if the floating body is slightly displaced from its equilibrium position by applying an external force, it gets slightly tilted. Like previously that body was in that shape, now you can say it is slightly tilted. Okay. The reason is that on displacing the body, the shape of the displaced liquid changes. Therefore, the center of buoyancy B shifts to the new position B dash towards the leaning side as shown in figure. Now, here you can say B, then B dash. That was previously the center of buoyancy. Now it is shift to the B dash side. The vertical line through the new center of buoyancy B dash meets this one, the old vertical line through the center of gravity G at point M. This point is actually called as the meta center. So this is B dash, this is G. Now you can say this is meeting at this, and now it is the M1. Okay, why? Because the previously this was the center of buoyancy. Okay, so that will known as the meta center. Depending upon the relative position of the meta center with respect to the center of gravity, the floating body could have the following three types of equilibrium: stable, unstable, and neutral equilibrium. For a stable equilibrium, if the center of gravity G of the body lies below the meta center M, then the equilibrium will be stable. This is the case when the body is heavily loaded at its bottom, then only this could be happen. Unstable equilibrium, if the center of gravity G of the body lies above the meta center M, the equilibrium is unstable. When body is heavily loaded at its top, then this could be happen. For neutral equilibrium, the meta center M coincides with the center of gravity G of the body. Then the weight of the body W1 and the upthrust W2 will be in the same vertical line, even in the tilted position. So they are actually balancing each other. That is known as the neutral. They do not form any couple. The body remains floating in the tilted position without an increase or decrease in the tilt. This type of equilibrium is also called as a neutral equilibrium. So with this, we have finished this lecture. It is requested to all of you kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.